Okay guys, so this is the MSI MPG Edge gaming motherboard that we were looking at last week, I think, the week before, and we basically traced the fault down to this regulator here, this VRM buck regulator, and we need to change it. Problem being is that it's very near to the DIMM slots. I do have some replacements now, so we can certainly give it a go. I think I'm going to try to get some leaded solder on here first. I mean, there's components around it, but there's nothing too close, which is not so bad. There's nothing this side. These are all empty places, basically. There's nothing there, so I can certainly come in from this side with a soldering iron. I will try using the preheater underneath the board to get it up to about 100 degrees, and I'll probably use hot air to remove the chip. Unless I can actually, we will try see if I can get in from this side with the soldering iron, and if I can actually get enough heat into it to just remove it without hot air. If that's not helping now, let's get the hot air, but we will use a preheater for sure. So first thing I'm going to do is try to add some leaded solder to the chip, and of course I'm going to put some flux on there. So some flux on here. And let's see if I can get some leaded solder. I'm going to come from this side first. It's going to be easier coming up this direction. Here it is. So where's my big roll of solder? One moment, because I can't see it. Okay, so I found it. That's another example why everything in the workshop should have a home, and it should always be at home, because otherwise when you want to find something you can't find it, and that's not really a good idea. Okay, so let's get a good blob of solder on the tip and see if we can get some leaded solder onto this chip, and go from this side and from this side. This should help to lower the melting point. Going on from this side, and the last side is going to be difficult. I'll see if I can get in from this angle. I'm not sure if I can, but let's try. Because obviously we're close to the DIMM slots, and there's a few components this side as well. Okay. I think that's got some leaded solder on there. If it doesn't, that's the best I can do, to be quite honest. Again, we'll come in from this side, and we'll try add a little bit more. Certainly on three sides of the chip if we can, and possibly on the fourth side. Okay, oops, sorry, I've got my head in the way of the camera. I'm sorry, I have to learn not to do that. Okay. That's the best I can do, getting some solder. Let's have a quick look on the microscope just to see what we have here. Is the microscope working? No, it's probably free. Okay, that's got the microscope working again. So, this is the chip we want to remove down here. We can zoom in on this a little bit, I think. Let's get a bit of alcohol. Isopropyl alcohol. Let's just clean that little bit of flux off from it. Let's just see if we did get some leaded solder onto the chip as we were trying to do. It's hard to tell. We may have done. If I just dry that off, I can certainly try now under the microscope and see if I can get some on there. Hold some kitchen roll. And just dry around this area. Okay. Yeah, I mean, you can see, I think quite clearly now, that I have actually managed to get quite a blob of leaded solder here and here. there's also a pin here. I believe there's 2 pins that side and then 4 either side. Can't easily get onto these ones. This capacitor's a bit lopsided and it's close. What we will do is just take a photograph of this, just to be sure if I do dislodge something that we know where it is coming from. Okay, let's grab get a camera, let's take a photo of this. Let's see what we have. Okay, that's the photograph of it. Let's see if we can get some down this back side again. I'd like to get some that side if I can. It might be an idea to just remove that capacitor actually while we try and remove the chip and then replace it. Let's give it a go anyway. Once again, a bit of flux. Microscope camera's frozen. 1 second. Okay, so that's the microscope working yet again. Yeah, looks like we've managed to do it this time. Let's just zoom in a little bit down here, even with the flux on the board. Yeah, I think you can see 2 things. I think first you can quite clearly see now that I have leaded solder on all pins, and secondly that I managed to straighten the capacitor up without trying. That's got to be a bonus. So this should come off fairly easily with hot air, to be honest, but let's just try. So we're going to come in from this side. I mentioned there was no components on this row, but in fact there's a resistor one there that I didn't spot before I was using the microscope. So on the desk cam I didn't see that. I managed to get a bit of solder on the end of that as well. So it's possible if I do use hot air, because some of these have now got leaded solder on them, they might melt. Well, they probably would melt at the same time this melted and come off. Yeah, so we're still going to try and come in from this direction, away from this resistor. Apply heat on the side of here with the soldering iron. I'll set it to the boost temperature. We'll put some hot air in from the preheater underneath first, and let's see if we can remove it that way, because if we can do it that way, that's going to be nice. I don't care what happens to this chip, because it's going to get replaced anyway, so if that chip gets roasted, I really don't care too much. Okay, so let's do that. Let's go over to the desk cam and let's see if we can get this set up and ready to work on it. Okay guys, so we're back on the overhead camera. We're going to try and warm the board up using the preheater. So we want the preheater, we'll want temperature meter, we'll want some Captain tape, so I can reach that from behind me. Yep, got the Captain tape. Soldering iron, don't think we'll need the solder, but there it is. This is the preheater. We don't need the brush just now, don't need the soldering iron bit spare one. Okay, so we have a nice clear area to work. So we're going to have to balance this board over the preheater, which is a nice little thing. This it cost about €40. You know, you can see it's a card at 853B. It wasn't expensive, but it's a great little tool for these sort of things. It's one of these things that you don't realise you need one until you've got one, and once you've got one, you wonder how the hell you ever managed without it. So I'm just propping something under this end to keep the board balanced. I don't want it falling over while I'm working on it. I've got the temperature probe. You should be able to see that. I'll put it in front of the camera. We're going to tape a probe over here. Try to get it so it's actually in contact with the board. That would be best. It doesn't have to be right next to it, just in the area. Okay. So a bit of Kapton tape for that. That's why I got the Kapton tape. Lots of ways of cutting this stuff. This is the easiest. Yeah. That's my method. See what people think of that. Okay, so I'm going to stick that to the board. There we go. So we've got a probe in the area. Now I'm going to try and get this area of the board up to about 100 degrees. Then use a soldering iron coming from this side and see if we can remove the chip. If not, we'll have to try some hot air. So I've got some tweezers. Let's now zoom the camera down. I'll have to manually focus it, so I'll see you in a second. Okay, there's the chip. That should keep my head out the way of the camera. I've put it a bit towards the back. You'll want to be seeing the temperature probe, so there's the temperature probe. And now we're going to power on the preheater, which doesn't come on as the cable fell out. Probably. Oh, now why doesn't my preheater work? One moment. Answer being because the power lid fell out. So that's the preheater on, fan on, heat on. We'll now start to warm this area of the board. Now we're going to do this gently, we're not going to rush. I want to get plenty of heat into the area. There's no need to rush while we're doing this. We'll see which way I'm going to get in at this chip. Trouble is I'm right-handed and I really want to come in from that direction. That's where I want the soldering iron. Let's see if we can get it from this side. No, then you can't see. Maybe that side. Try the slightly bigger ones. You can see the temperature's got quite nicely while we're messing with this. Okay, this is going to be difficult for me to do this, so I may end up blocking you guys from the view. I'm sorry, but it's most important that I get this chip off here without damaging the board, knocking other components out of the way, without damaging the DIMM sockets. Temperature's coming up nicely. We can give that a little bit more heat. Just turn the heat up a little bit. I think 100 to 120, something like that would be reasonable. That's not going to melt any other leaded solder, shouldn't be hot enough to damage anything, but it should be nicely warm enough to get some heat into this board so we can desolder this. Hopefully with just a soldering iron. While that's just increasing up, let's just see if I can adjust the focus slightly to get a little bit better focus on that. And get the microphone lead from underneath my chair. So I get a little bit better focus on the area, a little bit of zoom. Yeah, I think that's about it. Okay, so we're up to a temperature that we were looking for. That's nice. I'm now going to come with a big blob of solder, and from this side. Sorry if I blocked the camera. Got one big blob of solder. I'm actually sort of going to go on top of the chip itself, like. I'm trying to get a solder onto this chip so we can actually desolder. Let's see if we can remove this. I'm balancing the soldering iron directly on top of the chip. Nothing's happening, so I'm going to put boost on the soldering iron. That'll take up to about 380. Clean the solder off. Alter the focus. I'm sorry about that. I don't know why that's moved. Again, in from the side. Good amount of solder. Try to get the solder onto the top of the chip as well as on the pins. Let's see if we can remove it. We have it. Unfortunately, it's slid one way. Okay, I have it. It's off the board. I think the preheater obviously is up to 128 now. Let's turn the heater off. We'll leave the fan on, and we'll give that a few minutes to cool down. And now let's see what we have. Okay, so that's cooling down nicely now. It's down just over 40 degrees. I think even without the microscope, I think you can probably see that we've remove this quite well. You can see the 2 pins coming from this side, the one from this side. 4, that was like we got a little bit of a solder blob on here, but there's 4. The capacitor that was slightly out of line is actually in line. That's the little resistor that we had this side that I was a bit worried about. When I removed, I dropped it this way onto this capacitor, but because this capacitor has lead-free solder and this is leaded, I wasn't as high enough for temperature for this to melt. Also, bear in mind I was putting the heat in direct onto this chip from the soldering iron, so this would be about 125, which is the temperature I had the board up to. So yeah, that looks pretty good, but to be sure, we need now to get us under the microscope and just double check to see what we have. So let's make a bit of space on the desk, and then we'll go over to the microscope. But first of all, we'll just clear up a little bit. You can see how I'm focusing this now, can't you? Let me know what you think of the new camera setup. If it needs further improvement, we'll have to look at it. I might be a bit concerned about the performance of the PC. I'm not sure it's recording. I'm now running in full HD if it's recording all the frames. So I may have to put together, if I've probably got here, another faster computer. That might be a good idea. But anyway, for now we have what we have. So that was the preheater. These are just boxes I put here to balance everything, stop it falling over, so we can get rid of those now. This is my metal tray I've mentioned. I took a lid off an old satellite receiver. This is what I put boards on when I want to use hot air. Protects the mat, and it helps the board to get hotter, you know, because it's not conducting all the heat into the mat, basically. So that's that. I was trying to wedge it with that, but it didn't work. Let's tidy up this whole place up a little bit, and then let's see what we've got. Everything's back in its home. The chip, by the way, is still stuck to the end of the tweezers, so we can look at that. Let's see, did it survive? Although I wasn't overly bothered about it. Okay, we can go off now. Caught under some wire here. One moment. It's better. Right. Let's see what we've got, eh? Let's see what we have here. We can remove the heat thing now. Obviously the board's quite cool now. Well, we've been having a bit of a look at the job and chatting and putting the world to rights and that sort of thing. Okay, get rid of that. That can go in the bin. Aye. Okay. So, the big reveal, eh? The moment of truth. Let's see what the microscope camera says. Is the microscope camera working? That's another good question. No. One moment, let me just restart. I don't know why that camera does that. It's the only one that does. Maybe I'll try a different HDMI cable. I've got like an extension cable. Yeah, maybe I'll buy a new cable. It's like a B tap that plugs into the camera direct to an A drive. Okay, so where is it? Oh, it's here. That's the job. We need some isopropyl. We need to just clean all this flux off and get a good look at the work. Well, it looks pretty good to me, that. At first glance, even without the microscope, it looks pretty good. It's taking a bit of cleaning off this flux, as it's quite hard. Okay, well, that's about as good as we're going to get. Kitchen roll. I get through quite a bit of this stuff. Wife has to keep giving me another roll or two of it. Okay. Yeah. A bit of desolder braid. We have a bit of solder here and there where we don't really want. A bit of desolder braid, a bit of flux. There's a blob here. Anyway, I want to clean all these pins up now. I want to get leaded solder onto them. Looks like we got a bit onto the back end of this capacitor here. That's probably about the worst of what we did. Let's just see if we can just clean that off there. I'll try to do it this way. In fact, I'm going to look down the microscope. Just bear with me. I can see much clearer this way what I'm doing. That's cleaned. That's cleaned. Braid. Braid was bent. Okay, it was catching on something. Soldering iron in here. I'm gonna have to zoom this out. I'm too zoomed in. There we go. Yeah, that looks good. That's got rid of all the sort of mixed up leaded and lead-free solder. Sorry, your focus is that a little bit, guys. It was right for me in the microscope. Okay. Yeah, that's got rid of that. Clean it up again. So the fun now is how we're going to solder a replacement, eh? We've still got the same problem with being very close to this lot. 3 sides of the chip are not going to be difficult to get to. It's the 4th side that's going to be the interesting one, and how we do that. Yeah, look at that. Lovely, that's lovely. Look at that. That even looks professional. Okay, I'm gonna yeah, I'm not going to do anything really. I mean, that's nice, that is. I'm going to leave that as it is. So yeah, these chips, let's have a look at what we have. Let's get the board out of the way. Let's just get the, where are they? There they are, tweezers. That's the chip. Looks a bit messy. I mean, bear in mind I had the soldering iron directly on top of this thing to get enough heat into it. I'll stick it onto the desk if I can. It's very sticky. Where's it gone? Thought for a minute and the camera had frozen, it hadn't. There it is. Yeah, you can see the pads underneath it. Let's try and just clean that up with the end of the soldering iron. I'm just interested to see if it really survived nicely. This might stick to the soldering iron now, knowing my look. Let's just, yeah, it's now stuck to the soldering iron. Thought that might happen. Still stuck to the soldering iron. There it is. Okay, it's just off view. Let's bring that in the air. Yeah, that came off clean, I think. Can we get a bit of ISO on that? Not as it matters, this is the old one. I'm just interested. I'm interested, some of you guys are interested to see if that really came off cleanly. It's looking good. Sometimes I digress. You've probably noticed on these videos now, sometimes I have a habit of drifting off on things, but I hope some of you are interested. Okay, it's quite nice, that. Yeah. Is it burnt on the other side? Yeah, it looks a bit fried on this side. I'm not surprised considering what I did to it. No, maybe not. Maybe just as gunge that's on it. Stuck to the paper. Yeah. Looks like I fried a hole, and it effectively looks like I actually melted a hole in the top of it here. But that's okay, because we weren't bothered about it. We just wanted to get enough heat in to desolder it, and I'd say I've got to call that a success. As long as you're not interested in salvaging the chip, which we weren't, that technique works. that's basically what the guy told me to do, which on the last soldering video we were trying to do, and it didn't work very well. And I think the difference was this time I used the preheater, and the last time I didn't use a preheater. Okay, so we need to fit a new one. Let me first of all find the new one. Okay, so these are the replacements. I actually bought a pack of 5 of them because they were like about €2 each, and I thought, well, for €10 I may as well have 5. I can't work on the basis that I've seen something faulty once, I'll probably see it faulty again. So if they're not expensive parts, then I'll often do that. I'll just buy some. Yeah. For those of you maybe with a long memory, or if you've just watched the previous video, you remember the part numbers for these, like the first 2 letters refer to the part, and then M is a year and 202 is a batch code. And you'll probably notice that this actually has a different code than the previous one, FZ. I don't quite recall what the other one was now, but it's different. And the reason being, the original chip was MP2329C, and I couldn't find any of the C, but I could find the MP2329. And I asked on my favourite place, badcaps.net. I got the data sheets for the two. I said, look, I need to replace this, I can get this, is it compatible? And a couple of nice guys there came back and said, yeah, it is. There may be slight differences in the efficiency of it, but that's irrelevant. It'll work as a voltage regulator, it'll give the right voltage and it'll work. So we need to get that anyway onto the board. Underneath we can see the pads, same as other, short one, long one, one that side, 2 this side, say short and long, 4 either side. Easiest way to do this, in my opinion, is to get some flux on this and try to get some leaded solder onto these pins. Yeah, even if I then effectively use solder braid to get it kind of flat again, I want to get some solder onto these pins. You'll notice that the pins are underneath, so if you look at the side of it, can you see the pins kind of go round the side at a right angle? So from the side you can get to the edge of the pins. Just sort of the focus, you might see that better. Yeah, you see them now. So this is called a QFN. It's a quad flat, no leads. So I'm going to, so you get some flux, get some solder on the bottom of it, probably use solder braid to get it fairly flat, and then because I've put leaded solder on the board, I should be able to hold this in place with the tweezers, get the soldering iron up against the edge, and effectively the solder that's on the track should melt, and I should be able to solder it in place, not just one pin at a time, but just coming from the side. Yeah, one side is going to be close to the dim socket, that's going to be difficult. But we can do the other 3 sides first, and then see if we can get in at the last one with a small soldering bit. Once we've done that, we can use a test meter, so we can go across each of the 4 pins and make sure we have no short circuit. So we can test it before we power the board up. That's good. Okay, so that's the chip. So now, how do we get some solder on this? Well, first I need to get the thing into focus. I'm going to hold it with the tweezers and just bring the soldering iron in with some solder on. I'm not going to worry if I get a blob or a bridge or something, because I'll use solder braid afterwards, which will clean most of it off, but leave some there. I need to leave some leaded solder on here to get the thing to stick, basically. So once again, the soldering iron's not on boost anymore, it went back to 320 after a few seconds, so we can get some solder on here. We're getting some flux on the thing as well, that's going to help a lot here. I'm sorry if the focus is just going off on that. I think it's the bright light actually just shining, making it a bit hard for you to see. So we get in a better position. Yeah, it looks better, doesn't it? So let's get some flux on it. Bob of flux on it. Once again, let's get some fresh solder on the soldering iron. So I don't have 3 hands, so I have to get the solder onto the soldering iron first. So a nice bit of solder on the end of the iron. Yeah. I'm going to hold, microscope's gone again. One moment. I really don't know what's going on with that microscope camera. I'm going to buy another USB lead and see if that solves it. It's like some sort of interference, and it seems to be when I've got my soldering iron in use as well, in particular. Okay, so let's see again. Fresh solder. So a bit of solder onto the bit. Oh, a blob of dirty solder on that. Let's go again. Tip's nice and clean. Yeah. Some fresh solder. We'll hold the chip down and see if we can just put the bit flat onto it. That looks like it worked, doesn't it? A little bit more solder. Okay. I need to just clean it a little bit. I think I've managed to tin all the pins from that side there. Okay. Let's just clean that up a little bit and see if we've now got what we wanted. Oh, at least the microscope's still working. Bit of isopropyl again. Hold the chip either side. And the frozen. Stupid microscope camera. Ah, that's getting to be so annoying. I don't know what's happened here. Like we've got a blob of dirt, or we've lost a pad even. Let's just go again on that bit and see what's happened to it. Clean the soldering iron tip. Let's just see what's happened to that. No, it hasn't. It was just a bit of grubby. Okay. Yeah, that looks pretty good to me. Maybe a little bit too much on that one. Okay. Clean that up. This is another reason for buying more than one part, because, you know, hopefully I'll fix this with the first one, but if I mess it up I've got 4 more of them. Otherwise you have to wait a few more weeks again for, you know, it took me what, 2 weeks or something to get these since the last video. I thought I had them in stock and I didn't. Okay, that's nice, I think. Okay guys, so it's time that we fitted the replacement part to this motherboard. Ah, there you are, you can see me. Okay, so yeah, it's time we fitted the replacement part of this motherboard. I've actually tried this a few times earlier and recorded, although the microscope camera kept crashing, but I've tried a number of times to solder this with using just a soldering iron, and I can't do it. So no matter, I mean, I've tried about half a dozen times and it just wasn't going to work. So I'm going to post some outtakes at the end of this video, give you all a laugh at what was going on, but save you time if you want to watch them later. You can do, but I'm guessing you're more interested in seeing if we can fix this motherboard. So this is the chip. This is the replacement chip, and we can see that it's the right way round. So you've got the 2 pads at its top end. Yeah, I've got a bit of solder onto each of the pads underneath, and I'm effectively going to try and solder this now using hot air, because I just can't do it with a soldering iron. Obviously we have the dim slots very close, so what I'm going to do is I'm going to use the preheater to warm the board up to maybe 120 degrees, something like that, from underneath, and then hopefully use the hot air just to finish it off. So we know the chip was the right way round, it was that way round. I'm just going to show you actually. So yeah, that's the right way round, as you can see. Fell over, but it was that way. Right. You can hopefully see that there's a dot on the corner of this chip here. Yeah. And if you look at the place on the motherboard where it goes, just focus it. There's like a a marking here as well, yeah? So you'll almost always find this. You'll find a dot on the chip and a dot or a number 1 or maybe a dot here or a corner marking like this on the board, and that basically tells you which way round it goes. So what we're going to do is we're going to add a bit of flux to this. I've already put some solder on the board. I've tried to get a fairly even amount on each pad. It's a bit difficult to do, but there's some solder on each of the pads. So when the chip's sitting down on the pad, and bear in mind the chip already has a bit of solder underneath it as well, it should effectively melt underneath it and solder it in place. The best way to do this is going to be to get a little bit of flux on the board, just a small amount, yeah. Now let's move this chip out of the way a little bit because we don't want to lose the chip. At least we know which way round it goes without having to turn it upside down anymore because we have the dot that shows us where that goes. Can I even place it over here? Probably need both pairs of tweezers to do this. It sticks to everything. It's sticking to the tweezers, it's sticking to the other tweezers. There, we managed to put it down. I'm going to take a small paintbrush. Where's the camera? Yeah, it's just a little paintbrush. And I use this just to when I want to put a small amount of flux on the board. So I'm going to rub over here now. So I just have a small amount of flux. I don't want to flood underneath it. I want a bit of flux on it, but I don't want like too much. I don't want it floating around once we get the hot air on. Yeah, I want it to stay pretty much in place. And what should happen, the surface tension of the solder should actually pull this into place. I'm going to use 2 pairs of tweezers to do this because obviously it's hopeless with one. I'm going to look down the microscope as well so I can actually see what I'm doing. There you go, I managed to put it down this time. So we're going to position this chip so it's basically in place, which it is now. Now, you can't say exactly, but that looks very close to me. And to be quite honest, when we solder this, it should effectively come into place itself. Like it may move a little bit. Now let's see if I can get this. So that's in focus on my camera. Let me just try on the microscope camera, see if you can see better what we have. There we go. There's a slightly different focal point between the eyepieces in the camera, which is annoying, but nothing I can really do about it. Just moving the camera a little bit, see if I can actually. Yeah, that's kind of in focus. That's better, and yeah, it's in focus for me. That's good. Okay, so that's basically sitting in place. So we're going to use a preheater to warm this board up. And we're going to, let's say, get it back to 120 degrees, and then we're going to use the hot air from above. I'll put a bit of foil around the ends of these to try and keep them protected, and hopefully we should be able to solder this in place before anything else melts because this is leaded solder, and we hopefully don't damage these DIMM sockets. Okay, so I'll set up on the desk cam and I'll see you in a moment. Okay, so we have what we need here. I think we have the preheater. The Carlos 835B, as I mentioned before. We have the board, obviously. I'll find a couple bits of something to balance under the board so I can get to balance on the preheater. I can do with buying myself a little stand that fits over here, or I might make something out of wood actually. This should do the job. But for now, let's just balance this onto the preheater. It goes about there. I think this would actually work a bit better on the stand because with it balancing on the preheater, some of the heat's going back out into the preheater itself, if you see what I mean, which probably doesn't quite warm up so much. Just wedge something under here. Need to get the right balance. Yeah, there, Heath Robinson, but it did the job. So okay, we now have the board. Let's zoom in on the overhead camera as best we can. A bit of focus there. There we go. Okay, very particular that overhead camera focus, but a damn sight better than the other one we had. Okay, so there's our chip. So first thing I need to do is have a look to see if that's actually moved while I was moving the board over here. If so, we need to just get it back into place. So I'll use the little jeweler's loop here, and I want to see if that's actually That'll move slightly, not much. Let's just see if we can just get us back into position. Sorry, you probably can't see this, but I just need to do it. Where is it there? Tell you what, let's do it this way. Okay, just stopped having to look at the back of my head there while I was doing that. So yeah, that's in place. So we just get a little bit better focus on it. Even that I'll probably just do. Okay, so that's in focus. What I'm going to do now is I'm going to add a little bit of flux just around the chip, yeah. Not really on the chip, just around the sides of it. And the idea with this is that it should flow underneath the chip when we apply the preheater. So it's down there. Yeah, that looks good. I'll just check it. Okay, maybe a little bit more than we need, but it's there. The chip's in place. So what I want to do is I want to heat this up from underneath. Let's get the temperature probe on as well, so we can see what temperature this is getting up to. And I want to warm this up to where that flux starts effectively to smoke and evaporate. The idea being that that'll happen underneath the chip and kind of hold it in place, so that when I bring the hot air in from the top, it shouldn't move. Put the probe there, that should be fine, that's close enough. Okay, so let's start off with the heater. Heater on. So it's warming up quite nicely. Just setting my hot air now to a low airflow, say 15%. I've set it for 300 degrees, 15% airflow. That's on the quick. So when this gets up to a temperature where that flux is kind of like evaporating, I'm going to bring the hot air in from the top, and I'm hoping that the surface tension of the solder actually pulls it into place properly. Warming up quite nicely at the moment. I'll put a bit of tin foil. I'll do this while it's warming up. I knew I got the tin foil out for one reason or another. So to kind of protect the top of these dim slots as best I can from the heat, while still being able to get to the chip to work on it, yeah? Okay, that seems to have settled. Let's take the heater up a little bit. I'm going to warm this up a bit higher. I mean, often I go to about 100 degrees, 120. I'll probably take this up to about 150 or something like that. I definitely want that flux to start to bubble, smoke. I'll take up a bit more. We're at the magic 100. I'll just increase the setting of the heat up a little bit. Actually, it may even be possible to solder it this way, you know, just heating it from below. I'm not quite sure if we can do that without getting the bottom of the board too hot, but let's see. Obviously, the less stress I put on the board, the better. I would think that solder would have started to, sorry, that flux would have started to bubble a bit by now. Clearly it hasn't. A bit more. Obviously, I don't want to effectively blow this chip around the board, otherwise I have to start again. And I don't want to do this too many times. Not that I haven't got the patience for it, it's just that obviously it's not good for the board to be doing that. I'll get up to about 150 and then I'm going to start using the hot air. I was hoping that flux would have kind of like started to evaporate by now, but that's clearly not going to happen at this temperature. Okay. Let's see if we can now get in with the hot air. So I've got the hot air set to 300. I've got a slightly smaller nozzle than I would normally use. So hopefully... there it's going. That's smoking a little bit. That's what I wanted to see. I'm going to bring the hot air in now from the top. Don't want to melt the meter either. So let's move that a little bit. I know you can't quite see it, but I don't want to melt the slots. And I want to kind of get in now with hot air from above. And get this chip up to about 200 or so. That should be melting the leaded solder now. Let's keep it there for about 15 seconds. And if we've got this right, this chip will solder. Okay, I think that's probably enough. One final little bit. 220, I'm going to take it off. That'll do. I hope that was enough heat to melt the leaded solder. I'm now going to take the heat off from underneath and put it on to cool. If not, it should be stuck down now and I can probably get back in again. Let's have a look. I can't tell if that's moved or not. I honestly can't tell from this angle. Still bubbling a little bit, so there was obviously a lot of heat going under there, which is what we wanted. I think it moved. I don't think it's in place. I really don't. Okay, let's let it cool down and see what we got. Okay guys, so this is the motherboard after resoldering the QFN. Actually, it did move when I tried that, so I had a second go at it off the camera this time, and I used the same method. I figured out the reason it moved is because when the motherboard was balanced onto the preheater, and I'd used a cardboard box and bit to hold it level, it was actually sloping this way, so with the vibration of the heat it slid downwards. So I put it back on level. I desoldered it first with the hot air, I put it back on level, and this time I decided to get the preheater underneath to get the whole board up to about 180 degrees, which it did, and I then just came in with hot air and took it up to about 220, 240, something like that for 10 seconds, 15 seconds, and then let it cool back down to about 180. I had a second go with the hot air to about 230, 240 again for a few seconds, 5 or 10, not 10, 5 seconds or so, and then let it cool down. And this time it seems to be soldered. Because the board is level, it doesn't seem to have moved. So let's have a look under the microscope and see if this is now looking like a good soldered job. I'll just go to the microscope and see if it hasn't frozen. Okay, so that's the microscope cam working. Let's give this area a good clean now. It's had a lot of flux on it, heated up a number of times, so I want to give the whole area a bit of a good clean, to be honest now. And then let's have a look to see how this is looking. I'm just out of view there. I'm just cleaning this area up in general. Okay. Well, it seems to be solidly stuck down. Otherwise, the brush would be moving that, I'm sure. Right. Okay. So, bit of kitchen roll. Good old kitchen roll. And let's see how that's looking now. Okay, and I have to say that's looking pretty good. Let's have a look. Still flux around it, so I have to give it a bit more of a clean. See if I can actually tilt the board a little bit and we can actually try and look into the side of it to see if it's definitely soldered in properly. Yeah, it's hard to say. There appears to be soldered on all the pins, I'll say that much for it. no shorts. Okay, I think I'll give that another bit of a clean, and then let's just plug this in now and see what's happening. Hopefully we got 1.8 volts coming out of this, and then the other voltage, well, 0.3 will go up to its correct voltage, like 1.1 or 1.0, and with a bit of luck this will actually boot up. Okay, so let's put it back onto the rig and let's see what it does. Okay, so the motherboard's now on the bench. I've got the power supply attached, ATX power supply plugged in, processors fitted, put the CMOS battery back on, fan on, and it's ready to go. So we can now have a look to see the results of the work that we did in swapping this voltage regulator. But just before we do that, let's just remind ourselves of what the fault was on this motherboard, because it's been quite a while since I did the first video. Okay, so let's just go over to the desktop and have a look. Okay, so this is the voltage we found on the motherboard. Basically, this is the PCH, North Bridge, PCH, whichever bridge, South Bridge, and on this board that will not boot up, it will not start. We found when you have the standby, 5 volt standby from the ATX power supply, we have 0.7 volts here on these capacitors and 0.32 here, and that was suspiciously low. So I got another motherboard, Gigabyte, different make, but same chipset, and had a look on that one with standby, and that board does start up. It doesn't run, doesn't boot, but it does start. And on that one we had 1.8 and 1.1, so we know these voltages are too low. So we did a bit of circuit tracing, and the 0.7 volt comes from this coil, which is controlled by this buck regulator controller here. Yeah, it has 5 volts coming in from standby as we'd expect, but 0.7 coming out, which instead of 1.8. That's why this is low. The 0.7 also goes to this voltage regulator, low dropout. This is not a buck regulator. Look, there's no coil. Yeah, this is a linear voltage regulator. 0.7 coming in and 0.32 coming out, and that's the 0.32. And we figured out that because this one's low, the voltage going to this one is low, so the voltage coming out is low. So the whole cause is the fact that the voltage here is too low. And having checked around a few resistors and capacitors here, which I'll show you, what do we do? This is where we checked. This is basically the circuit we have on here. So this is part of the chip. Pin 1 at the top, this is 5 volts, and we know it's 5 volts. All the pins down this side are ground, so we can ignore them, yeah? This is the output to the coil, and we know that this is 0.7, yeah, it's wrong. And then here on this side we have VCC. This, if you look at the data sheet, this VCC is generated internally from the chip itself. Let me see if I actually have that. Yeah, this is a chip, yeah? And VCC, if I just go to the pin description, which is somewhere in here, was probably, oh, there it is, I thought it was filled up. So VCC is an internal voltage, yeah, from the low dropout regulator output. So internally in this chip is a voltage regulator, and that's what creates the VCC here, yeah. Here you can see it again, look, this is like a functional block diagram of the chip. So we can see that coming in, voltage in, goes to this reference, and that generates VCC. And on our chip, the VCC was low. VCC is low, and the output is low. But all the resistors and the circuit, this checks out. Enable is 3.3, we're enabled. Feedback is a proportion of the output, which seems okay. VCC isn't short to ground, it's reading 2 meg, and yet we don't have any VCC, which we should have. So we figured it's going to be the chip, yeah. That's where we got to, how we got to where we are now. So let's just remind us on here. So 11 is the enable on this resistor, 10 is feedback, we're not too worried about that. VCC is on this capacitor, and your outputs here, yeah. Right, let's go back to the board now. Let's see if it works. Let's see what we've got. Okay, come back over to the desktop. There we go. So what we're interested in is, well, first of all, does it start? Yeah, let's just switch it on. Power supply's on. We can just check. We've got 5 volt standby coming in. So I'll just go to ground and the purple wire. 5 volt standby is good. While we're at it, let's see. We should have 5 volts coming into this regulator. Yeah. And VCC should be on this capacitor. And we don't seem to have. This is worse than it was before. This is 0.2. We had about 0.7 before. So I'm sure this is soldered right. I think that the thing with this would be, I've got some more of these. I had to try to solder this one about 6 times before I actually got it to solder in the end, and it's possible I've damaged it. So I'll put the other one on. Let's put one of the other ones on, yeah, and let's see if that helps. I'll do it off camera because you've seen me do this before, so it'll be the same process as last time. I'm going to change it again. Okay, well that doesn't take so long when you're not doing it on camera. I've changed the regulator, and being a sort of impatient sort, I tried it, and we still have 5 volts coming in, and we still have 0.22 volts coming out, and there's no way resistance from here to ground, and that's it's not what I expected. The fact I've got the same voltage now with 2 of these makes me suspect they're not compatible. I mentioned earlier that it was an MP2329 2239C, and I couldn't find the one with the C. I could only find the ones without the C. Yeah. And I'd asked on Bad Caps forum, and people generally thought it was compatible, but it appears it isn't. I don't know. I can't think of any other reason why I've not got the right voltage, and why I've got the wrong voltage twice with 2 different chips. Even if it wasn't soldered right, you think I didn't solder it right. Just not solder it right the same way the second time seems a bit like remote to me. So that's interesting. It's possible we can't find the part that we need, yeah, but that doesn't mean we can't repair it. What we could do is replace this buck regulator with just a linear LDO voltage regulator, something like I'll just switch this off, by the way, because it's switched on. One of these. I've got a couple of these. These are salvaged. Yeah, these are salvaged. I don't remember the exact pin. I have to look it up. But basically, the middle pin is connected to this metal tab, yeah, and the middle pin is the output. And these are 1.8 volt regulators, so you can put at least, more than 5 volts. You put a voltage input in, so we can put 5 volts into here, and we can effectively just connect the output to here. So if I was going to do this, I'd probably unsolder this coil, yeah, and I'd mount this so the output terminal, the tab, is there where the output of the coil is, yeah, and then the middle leg I can cut off because I don't need it, because it's the same as the tab, and then one of these is input and one of these is ground. So whichever's one, I can then connect a little wire to ground. I can probably come from either side of this capacitor here, because this is where I've got coming in. I've got 5 volts and 12 volts, 5 volts and 0 on this capacitor, yeah. So I could take 2 wires, hopefully the right way around, and connect 5 and 12 and solder this down instead of that coil. And that would give us a 1.8 volt voltage regulator. Parts 1117 1.8. These 1117, the voltage regulators, They come in various 1.8 volt, 3.3 volt, 5. There's one that says ADJ, which is adjustable. Yeah. The only thing with that is that this buck regulator can supply about 6 amps, and these can only supply a couple of amps. Yeah. Also, a buck regulator is very efficient, so it doesn't generate much heat. These will generate heat depending on the voltage drop. The bigger the voltage drop between the input and output, the more heat they generate. So if you think, well, we've got 5 coming in and 1.8 going out, so you're dropping 3.2 volts across the regulator. Yeah. Doesn't sound like a lot, does it? 3.2 volts. But if that's supplying like 2 amps, that's like 2 times 3.2 is 6.5 watts. That's a lot of heat. If you're supplying 1 amp, it's like 3.2 watts. So this would only work if this regulator is supplying a low current. And I know it's a 6 volt regulator, 6 amp. But this supplies the standby voltage to the PCH, and I can't imagine that actually draws much current. Yeah. I would imagine that off the standby supply on the ATX, well, I can't get in because the meters in the way stops me moving the board. I can't imagine on the standby rail it's supplying much power. So that's a way around this, and that's just something you can do. Sometimes where there's buck regulators in other situations where they're not supplying much current and you can't find the part. Yeah? Don't expect you're going to do this on VCore and GPU power supplies, lots of phases. You're not, but for power supplies that are not providing much current, you can do this. It's a bit of a Heath Robinson. It'll look a bit messy, but it would be interesting at least to prove if the board would work, to see if it would work. But actually, there's another way to do this without going through all that effort. There's another way to see if this board will work if we get 1.8 on here. Where are we going to get 1.8 volts from? Well, I've got, and I hope you've got, because you'll need one for this sort of work, a bench power supply, variable power supply that you can set anything from sort of 0 to 30 volts on mine, 0 to 60 on the other one. And not only that, if we use the bench power supply to put the 1.8 into here, we can also, looking on the meter on the front of the power supply, see how much current it's drawing as well. And that will tell us 2 things. That will tell us firstly whether or not putting the correct voltage on this does make the board boot, and secondly it will tell us whether or not we could put a linear voltage regulator instead of this and get it to work. Yeah. Okay. Somebody called those things ghetto mods. Ghetto mods. I don't know exactly where the term comes from, but it's kind of where you botch it. Yeah, you botch something to make it work. But yeah, what do you think of that? But get into the comments. What do you think of that strategy? But first of all, let's get the bench power supply and let's put the 1.8 volts onto this coil. I'll leave this in. I'm not bothered about this being in the circuit. If the 1.8 goes back into that, it's not going to harm it anyway. Put the 1.8 on here and let's see. We should then have the 1.1 should be present on the output of this regulator. That'll prove that as well, and it might even work. Right, guys, let me just set up the bench power supply and meter so you can see it, and then let's give it a go, eh? See the meter or two. Okay, we're just about ready to go with that. So I've got the bench power supply. Yeah. It's not connected yet. I'm going to take the negative connection from that and connect it to ground on the motherboard. I'm going to use one of these mounting screws for the M2 hard drives, because that's a good place to get a ground on there. Yeah, this is the ground from my voltmeter, 1 volts range. This is connected to the positive of the power supply. Yes, this is where I'm going to come in with the voltage on the motherboard. This is the positive of the meter. So first of all, let's set this. We want to set it to 1.8. Yeah, I'm using the voltmeter as well because it's a little bit more accurate than this. which one is it? Voltage is here, yeah. I've used it back to front now, so you see. Okay, so that's close enough. 18.16 volts, I think we can live with that. So we've got 1.8 volts now coming in, yeah? I'm now going to turn the ATX power supply on. I think it is on actually. Let's just check on the 5 volt standby. Yeah, we've got 5 volt standby, so it's on. I'm going to measure initially on this capacitor here. This is the input from the coil here. So you can see that this at the moment's got 0.22 volts on it. Yeah, I can get that up here. 0.22 volts. Yeah. I'm now going to come in with my 1.8 volts straight into this coil. Okay, let's see what we get. Well, we've got 1.8 volts. You can see on the voltmeter measuring from this capacitor. So output of this regulator, this is the one that was dropping it should be to 1.1. Maybe it should have ended the capacitor. Yeah, it was there. I had it. 1.02. That's close enough at 1.1. So we've now got the voltages, which I should be able to see actually on the north bridge itself. Let me zoom the camera in a little bit for you. One moment. Okay, so I'm injecting the 1.8 volts into the coil here, yeah. And we check on this capacitor here. This is the 1.1. We've got 1.1. So if we get onto the BGA now, I should be able to see that 1.1 on that one. It's one of the capacitors here somewhere. Maybe it's the next one. Yeah, we'll call 1.03 close enough to 1.1. And then up on these capacitors here on the BGA, we should have the 1.8. If I can just get a connection on there. Yeah, 1.76. That's 1.8. So we've now got the voltages on the BGA. Let's see if it starts. No, it doesn't. Nothing still happens. So it's still not started. Even with the correct voltage on here, when I'm pressing the switch, nothing's happening. I can't see the fans are not spinning yet. It's not powering on. So that's a bummer, isn't it? Because we've now got the correct voltage in, and we still don't have this working. Nothing's getting hot. You can see actually you can see over on here on the side here 0.11. So it's drawing 110 milliamps, which is reasonable, I think. 110 milliamps on that. So if we did change this with an LDO regulator, which was dropping from 5 to 1.8, 3.2 at around 100 milliamps is like 0.32 watts. So that would work. That ghetto mod, that would work if we can get this to work, and we can't get a replacement for this. That would get this working if it works. Another thing I've noticed with these is that obviously the CPU's cold because there's no power on. I've noticed looking at these boards before, these AMD boards, they won't start up if the CPU isn't fitted. Yeah, and I'm just wondering if another possibility, I've got a bad socket on this CPU socket. I'm just gonna do that quick. I've just released the CPU, yeah, and the current's gone down to about 0.09 or 0.08, and when I put it back in place, it's back up to 0.11. So there's like 3 more milliamps flowing when that CPU's in, which makes me suspect there's a little bit of power is going to the CPU for the part of the circuit that effectively tells the board it's inserted. So at the moment I'm a bit of a loss to say how to proceed on this one. We know this PCH, I'm sure we measured the resistance from the capacitors to ground and compared with the one on the other board. I'm going to do that again. I'm going to measure resistance off this one, yeah, and we'll make a note of those. And then what I'm going to do is I'm going to look back at the other board, the one that does start up but doesn't boot. See if we can get any further with that one, because we didn't look at it before. We just said we'll try this one first. So let's have a look at the other one. the Gigabyte, and if we can get further with that one, then maybe we can get further with this one. But at the moment, guys, I have to say this one's just on the back burner. Have a think about it and see how we can proceed further. Okay, guys, see you soon in the next video with the other X570 board. See you soon.